So al-Khwārizmī did a lot of work with quadratic equations, and he came up with 6 different rules to help solve and look like the format of our quadratic formula. But one of them he did not include was x squared plus bx minus c. So if we think about y, let's rewrite this as x squared plus bx plus c equals 0. And we think about, well, what's an easy quadratic equation that does this? So x squared plus 5x plus 6 equals 0. If I follow our modern methods and factor this, that would be x plus 3 and x plus 2 equals 0. And this would mean that my two roots would be x equals negative 3 and x equals negative 2. And the problem with that is that both of those are negatives. When we think about what was al-Khwārizmī able to solve, he was always solving for positive solutions. This is the case where neither solution is positive, therefore this would not have been included with his 6 rules. Now let's look at some of those types of equations that he may have done. So here is x squared plus 17x minus 16. If we look at the 3 most common, this follows the first pattern, where I have a coefficient of 1 for my a, I have a 17 for my b, and 60 for my c. And so I can now substitute those values in because my x value is already 1, and it's in that format. So I have the square root, the quantity 17 halves squared, plus 60, and then that's going to subtract 17 halves. So I'm going to square the 17 halves first, which gives me 289 fourths. So I'm going to change this to 240 fourths so that I can actually add them together. This then will give me the square root of 529 over 4, and then we'll subtract the 17 halves. Well, 529, its square root is 23. Square root of 4 is 2. So now I have 23 halves minus 17 halves. That's 6 halves, which is 3. So the positive root for this quadratic equation is 3. All right, let's look at the second equation where we have 3x squared minus 12x minus 96 equals 0. In all these equations, the first thing I need the coefficient of x to be a 1. So I'm going to divide all 3 terms by 3. This gives me x squared minus 4x minus 32 equals 0. The next thing is al-Khwārizmī didn't want any negative terms, so he would have added 4x and 32 to the right-hand side, so that now we're left with x squared equals 4x plus 32. If I look, that follows one of the 6 foundational rules that he had. So let's substitute them in to solve this quadratic equation. So x will equal b over 2. So I have a is 1, b is 4, and c is 32. So 4 over 2 plus the square root of 4 over 2 squared plus 32. I simplify that. That becomes 2 plus the square root. Well, 4 over 2 is 2. 2 squared is 4 plus 32. So this gives me 2 plus the square root of 36. So I'm going to just carry this over here. So I've got x equals 2. Square root of 36 is 6. So x would equal 8. And so my only positive root for this quadratic equation would be x equals 8.